Okay. All right. So anyway, we kind of got into this break in an awkward time. We were done with all the material. If you remember, we were ready to take the test. We were going to review that Monday and Tuesday and then test Wednesday before spring break. So that's mainly why I wanted to just take, these 3 days, review the material, and then take the test. So the test is scheduled for tomorrow. So one thing I want to do, I want to go through all the equations. So I think, do you guys see the equation sheet here? I think you see that. Wait, Richard said yes. Is that to this question? No, that's not.
I see it. I'm pretty sure everyone sees it.
Okay, thank you. I have the chat thing open. So as I'm going through any of this in this whole session, if you have a question, feel free to just type it in there. You can mute yourself if you want. You can turn your video off if you want. Do whatever is good for you. Or if you just want to sit back and listen, that's fine too. But I'm going to be watching that chat window for any questions, and I'll try to address those as we go through. Okay, so I'm going to... I haven't found a good way to do this yet, so hold on. Oh no, oh no. All right, my stylus had some issues. Okay, I think I got it. Okay, here we go. All right, so the first set of equations, by the way, this equation sheet, it is on Canvas, and I had at least one student have trouble opening it, so I did convert it to a PDF. That's on Canvas as well. Please let me know this afternoon sometime if you're not able to access the equation sheet, because you're going to need that for the test tomorrow. So anyway, these first sets of equations, generally they're going to apply to a uniform electric field. So I'm going to draw one here. Whenever you get a question about a charge moving in an electric field, draw a picture. The odds are much higher that you're going to get it right if you have a good picture drawing. Okay, so I normally draw the electric field going left to right, just because that's what I do. You can draw it any direction you'd like. But remember, the electric field always goes away from a positive and toward a negative. That's going to be important for some of these equations. Okay, so the first one is talking about the delta V. If you remember, that's the change in potential or potential difference. So this plate has a potential, this plate has a potential. The positive side is always the high potential, and the negative side is always the low potential. Doesn't matter what's in that field, if anything, that's always going to be the case. Okay, so if you have a charge moving this direction in the electric field, it's going from a higher potential to a lower potential, so it's decreasing its potential. So its change in potential or potential difference would be negative, so that takes care of that sign there. And if it's going this way, you're increasing potential, so that'd be a positive change. And then for, to use this equation, you'd need to know two of those three things. You've got the distance a charge moves, or the electric field strength. Okay, you need to know two of those three things. I do want to remind you guys that if you have a charge moving perpendicular to the electric field, it's going to have no change in electric potential. So I don't care what the D is. I might try to trick you and say, hey, 2 centimeters this way. Well, you should recognize that this is a zero change in electric potential. So delta V equals 0 there. Okay, next equation. If you were given, a charge is at this potential, what is its potential energy? Use that equation. It's pretty straightforward. Now, the third one is very similar, but it's a change. So this is where you would have a charge moving within an electric field. Okay, again, it has to move either with the electric field or against it to have a value there. If it moves perpendicular, its change in potential is 0, therefore its change in potential energy is 0. Now, in terms of potential energy, you guys remember, if you have a positive charge and it's near the positive plate, it really wants to spring away. It has a lot of potential energy here, whereas that positive charge at the negative plate, it's happy being there. It's like a ball on the ground. It has 0 potential energy. Okay, the opposite's true for a negative charge. A negative charge would have a lot of potential energy at the negative side it wants to bring away. And then a negative charge would have very little or zero potential energy at the positive plate. So that's how we can get the sign for that change in electric potential energy. You have to recognize what the charge is and which direction it's moving, okay, whether it's going to gain potential energy or lose, okay? So depending on what information you're given, these two equations would come into play here. If you know the charge and the electric field strength and you know the distance it's moving, you could use this one to get the change in energy. If you know the potential difference, like you might be given this whole distance between these two plates and you're bringing a charge from here to here. I'm sorry, I'm kind of repeating that one. You might know, the voltage here and the voltage here. So you know the delta V. If this is 6 volts and this is 0, our delta V is 6. And if we're given the charge, we could figure out its change in energy. Okay? And then F equals QE. You might need that equation. Again, that's just the force on a charge in an electric field. All right, everybody good so far? I don't see any questions here, so I'll keep moving. Again, just type a question in there whenever it comes to mind, and I will get to it. Okay, so the next set of equations, I want to emphasize, the heading is capacitors. And I'm going to write only in there. You can only use these equations for capacitors. So only if the problem says this is a capacitor should you be looking at these equations. Any other context, I would not use these equations. The energy ones are where a lot of people get confused. They'll try to use these in a different situation. Don't do it. These are only good for capacitors, okay? So the first equation, C equals Q over V, that's the basic capacitance equation. If you remember capacitance, the units are farads. And then you've got charge per volt, so coulombs per volt. So 1 farad is 1 coulomb per volt. So a specific capacitor, though, we talked about those in class, the parallel plates. I'm going to try not to get too messy here, but if I can draw 2 parallel plates. Okay. When you charge these up, meaning you're going to hook a battery, which gives a potential difference across these plates, it's going to pull electrons off of one and onto the other, okay? And then when we release them, we discharge the capacitor, and then it does whatever it needs to do. But anyway, the capacitance is based off of the area of one of the plates and the distance between the plates, okay? And that's through this equation, okay? The area, it could be a square, it could be a rectangle. I'm not going to give you a weird shape like that, but, and then epsilon naught, that value is down, it's down below, we'll see it in a minute, but that's a constant, okay? So the capacitance depends on the physical dimensions of the capacitor, so the area of the plate and the distance between them. Okay, you might look at this equation and say, well, doesn't capacitance depend on charge? Doesn't capacitance depend on the voltage? No, okay? So this comes into play. First of all, for a single capacitor, the capacitance is a set value. So if you increase the potential difference across the plates, you're just going to store more charge. Okay, if you double the V, you're going to have double the charge. Capacitance remains constant. Only if you change the dimensions of that capacitor will that capacitance change. Okay, and then we've got the 3 energy equations for the capacitors. Again, only for capacitors. If you know the charge and the voltage, use that one. If you know the capacitance and voltage, use that. If you know charge and capacitance, use that. Okay? So that's really it for capacitors. We good on that? Okay. All right, next we get into more of the circuit stuff. Okay, so here was our definition for current. I is current, and then Q is charge, T is time. So we've got coulombs per second. The units for current, coulombs per second, which we also call an amp. Okay, an amp is a coulomb per second. All right, so that was really it. So a problem like that is you could have a wire and you have 4 coulombs pass through this wire in 8 seconds. what's the current. So you just go 4 coulombs over 8 seconds, and you could get the current that way. Okay, next, resistance. Okay, resistance. We've got resistivity. Remember, that's a material property. So each material has a resistivity. And all copper, at least for our purposes, all copper has the same resistivity. All aluminum has the same resistivity. It's material dependent. You can have totally different wire, same material, it's going to have the same resistivity. Now, the resistance depends on what material it is, the length of that, I'll just say wire in this case, and then the cross-sectional area of it. Okay, so for our purposes, we can always assume a circular cross-sectional area. And you know how to calculate that, right? Back from geometry, okay? All right, so we'd use that equation if you're given length and area and you want to know resistance. All right, the next equation is resistance based on temperature. I don't know if we did very many or any calculations with that equation. So I'll tell you now that you won't need to use that equation tomorrow on the test. What I do want you to know is how temperature affects resistance. So if you have an increase in temperature, you're going to have a higher resistance. If you have a decrease in temperature, you're going to have a lower resistance. It's really that simple. And that's the idea I want you to remember for the test tomorrow. Okay. This equation, I think we don't really need. It's really the same equation, but with resistivity instead of resistance. Okay. That won't come into play. And then we've got the big equation that's little. Ohm's law, V equals IR. Not much to say about that. I think you're familiar with that. Oh, I did have a question yesterday on Canvas. I hope you saw that. Nina asked the question about units with that and power as well. I typed out a long explanation for that. I hope it makes sense, but it's important to be able to recognize units. You're going to have, for sure, a question or two tomorrow that you need to be comfortable with dealing with the units. Okay, so here's more power equations. Don't get them confused with the capacitor. Okay, here if you have current, okay, current going through a circuit, we've got our 3 power equations. I think you're pretty familiar with these. Again, you can use any one of them depending on what you know. And then we've got resistors in series and resistors in parallel. And then that's how we add them. So again, I think you're good with that. I did post a video a day or two ago, it's a long week, just going through adding adding different combinations of resistors. So if you're not good at that, make sure you check out that video. It should help refresh your memory on how to do that. You will have to do some of that tomorrow on the test. Okay, and then hold on, I gotta figure out how to. There we go. I have to move so much of this stuff around to figure out how to do that. Okay, and then we've got the constants down here. We've got, I don't think we need that one. Sorry, that was more last unit. Coulomb's constant. That won't come up tomorrow. This one you should be familiar with. That's that elemental charge. So a proton has a charge of positive 1.6 times 10 to the negative 19 coulombs. An electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. Mass of an electron, mass of proton, and then there's that epsilon naught for the capacitor equation. Again, that's only for the capacitor equation. We've got our kinematic equations if you need those, Newton's second law, and then kinetic energy. So if you remember, we have problems, you know, on that group quiz was one. By the way, check out that video if you haven't already. But if you have a charge released in an electric field, and we want to know how fast it's moving after it travels a certain distance, I like to use primarily this equation, okay? Usually you'll know the potential difference, you know what the charge is, you can get that change in potential energy. If you're releasing the charge, like if I release a negative electron here, it's going to go this way. It's going to lose potential energy. Well, where does that potential energy go? It goes into kinetic energy. So the amount of potential energy you lose will equal the amount of kinetic energy you gain. So you can solve for that change in potential energy, set that equal to change in kinetic energy, and get the speed that way. Okay. All right, so that was a quick summary of the equations. Any questions on the equations? Just go ahead and type them in there if you have anything. I think that's really it. So you should print this sheet out off a canvas, or if you're unable to print, copy the equations down, make sure they're legible. I'm sorry we have to do it under these circumstances. I wish I could provide that for you, but we have to work together on that. So those are the equations. All right. Next. Yeah, let's do this next. Okay. Let's talk about the test. Okay, so tomorrow, I'm going to have the test available from 8 a.m. to 4 p.m. And it will be in Canvas. You just go to the Canvas page. And it'll be under quizzes. It may show up on the main screen. I don't know. But if you click on quizzes, you should see it. There's a couple things in there right now. I'm going to delete those. I'm going to make sure there's only one thing you see there. You can take it any time in this window. You can do it at 11. It doesn't matter. Whatever works for you. It will be open, or I'm sorry, once you start it, you're going to have 75 minutes to complete it. All right. Now, that should be way more than enough time you need. I expect most people would get this done within 40 minutes. It is 20 multiple choice questions, so I figure an average of 2 minutes per question. 40 minutes is probably reasonable, but just in case, I'll have it open 75 minutes. So should be plenty of time for you guys to finish that. Now, with that said, I am not familiar with Canvas quizzes in that I have it set to end at 4 p.m. So if you log in at like 3:45 and you're in the middle of the quiz or test, I'm guessing at 4 p.m. it will lock you out. So don't do that. Try to log on and start it. In fact, I will say start by 2:45. Okay, that gives you 75 minutes before that 4 p.m. deadline. If for some reason you cannot work within this, or you're going to be a little bit later than the 2:45, please send me an email. Don't start it and hope for the best. Send me an email, and then I'll figure something out to how to accommodate that. Okay, so that's the test. All right, let me know if you have questions about that. I want to talk a little bit about what's going to be on the test. Okay, so the review really covered most of what's going to be on the test. All right, you're going to have at least one capacitor question somehow. You're going to have a charge moving an electric field. You might have to solve for the change in energy. You might have to solve for, how far it goes, how fast it's moving, something like that. We kind of talked about those a minute ago with the equations. It's kind of heavily weighted on circuits. Okay, so one thing, I pulled the test questions from the textbook, the test paint for that, and I just want to make you aware of how they've drawn a couple of the circuits. Okay, so a couple things, you might see something like this. They call this point B and this point A. And then in the question it says there's a potential difference of 5 volts across A and B or something like that. Now, the questions where it did that, I did put a note in there saying this, but I'm going to explain a little bit right now. That's really the same thing as if you had a battery connected between points A and B. Okay, so I could redraw this like this. And by all means, have plenty of scratch paper ready. Redraw anything you need to redraw. Okay, so really these two things are going to be the same. Okay, and what I say, 5 volts, whatever, just whatever the situation is. Okay, so I don't want that to throw you off, to confuse you. I'm just giving you a heads up. I think you should be okay with that, but just in case, that's how you deal with it. So it might ask you for the total resistance here. So you just these two are in parallel, and then that's in series with that. Again, review that other video if you're confused about that. It might ask you for the current in one of the resistors. It might ask you for the voltage drop across one of the resistors. It might ask you for the power dissipated by one of them. Remember, that would be either IV, I squared R, or V squared over R. Some of those questions, it might look simple, like a simple, hey, what's the current through this? Well, in order to get that, you really have to get the total resistance, total current, you know, and then work with voltage, kind of treat it as an entire circuit. So that might take you a couple minutes to get through questions like that. All right. One thing I want you to, you know, be smart about this. You can answer multiple choice questions. Some of them you can answer without calculating. Okay, for example, you know, if we're given this situation, and let's say this is 4 ohms, and let's say this is 2 ohms, this is something. But anyway, let's say you solve for the current. The total current, you get 1 amp. Okay, now you guys remember that total current is gonna split when it gets to a junction. I'll call this I1 and I2. So you know the current going into the junction 1 has to equal the current leaving the junction, I1 plus I2. Okay, so that hopefully you're familiar with. Now, how does that come into play here? Well, you can look at these resistors. Okay, will the current split evenly, 0.5 and 0.5? I'm going to say no, because these two resistors are different. Okay, which current will be bigger, I1 or I2? I'm going to say I2 because it has less resistance here. Okay, so current generally is going to follow the path of least resistance. You're going to have more current where there's a smaller resistance. Okay, so what do I know? Well, I know it's not going to be 0.5 and 0.5. I know this one's going to be bigger than this one. So right now, I know this current's going to be between 0.5 and 1. Can't be bigger than 1, can it? Okay, so multiple choice, maybe there's only one choice that's between 0.5 and 1. I'm going to click that and move on without even calculating it. Okay, now you might have a couple choices in that range. Okay, well, you narrowed it down at least, but at that point you might have to do more. In that case, I'd probably look at voltage. You could figure out the voltage drop here. You know the total is 5, so let's say this is 3. You know you have 2 volts left, so this would be 2 volts, and this would be 2 volts, or something like that. Okay, which actually that's not possible. Sorry, because now I'm getting more current than I should. That's what I get for making up numbers. But anyway, any questions about things like that? I'm seeing no action in my chat box. I should check, make sure you're all still with me. Yeah, no, 19 people. Yeah, you're all still here. Okay, you're all okay?
Yeah, we're here. Yeah.
Okay.
Yeah.
Now I just gotta notice my internet connection is unstable. So go ahead and type a comment in if you lose my voice, or is my voice lining up with my actions?
Your voice was cutting out a little bit there, but it caught itself back up pretty quick.
Okay. All right. Maybe I'll just talk slower. Okay. All right. So again, you're going to have a few circuit problems. So like I said, have that scratch paper ready. Have your calculator. I think I put in the email what you should have. Calculator, scratch paper, equation sheet, pencil. Okay. All right. Other things on the test. Again, it's going to be similar to the review. Why don't I just go to the review here? New share. Where's my... How come oh, come on. It wants to share with my iPhone. I don't have an iPhone. Maybe I'll try screen. Do you see the review?
No. Oh, yeah, there we go.
Yeah, review. Okay, all right, good. Okay, question, how much is this test going to affect our grade? It depends. So given the circumstances we're under, and this is coming from the state even, so it's not a Warren thing necessarily. To be totally honest, whatever your grade is right now, it cannot go down. Okay, even if you fail this test miserably, I'm still going to enter that grade. But once we get out of all this, if your grade went down in the end, it's going to default back to what it is today. To be totally honest with you. Now, I know some of you, that just gave you permission to blow everything off and not care, and that's fine. But the reason for that is, not everybody, not every student in the state, at Warren even, has the technology access to do all the work that might be required. The other thing is we have enough things in the world to worry about right now. We don't want this to create an extra burden on you. I'm guessing some students are sick. Maybe they have a family member that's sick that they have to take care of. Maybe they have to go out and get a job to help support their family. So there's a number of reasons for that. So anyway, to be totally honest, this will not hurt your grade. It can only help your grade. My recommendation is you do the best you can on it. Still take school very seriously. I'm expecting you guys to take physics in college. This will give you a very good preparation for that. So good question. All right. So the review, first of all, the review, I posted this solution already to Canvas yesterday. Number 9, don't worry about number 9. It just gets kind of nasty in there, unnecessary complications. I'll just skim through this, but number 2, the answer is 0.3 volts, but it should be negative. That's a typo in there. Maybe your copy, I fixed that, I don't know, but that should be negative. But here we're talking about charges moving in electric fields. Like I said, you're gonna have to do at least one of those. It's kind of a similar thing. Capacitor questions. The review's got a few questions on capacitors. I'll be honest, and there's only 1 or 2 you're going to see tomorrow on capacitors. So don't spend all your time with that. Okay, this is one like how fast is it moving? So this is a good one to, I found the change in potential energy. So whatever you lose in potential energy, you gain in kinetic. You can solve for the speed through kinetic energy. There's just a current one. Units, awesome. Okay, like I said, that question that was asked on Canvas yesterday, I talked through some units on that. Be comfortable with those. Resistance, I like to ask questions like that. You double the length, double the area, what happens to resistance? Things like that. Oops, I'm unstable again. Power. Yep, those are always good questions. Okay, I'm seeing a resistivity question. Okay, hold on a second, we'll get to that. Resistors, series, parallel. You may be given a word description of a circuit that you're gonna have to draw out like this. It won't be any more complicated than this though, so it won't get too in depth. That's a good one. Okay, Christmas tree lights, holiday lights, whatever you want to call them. Typically, we look at those as wired in parallel. Now, there is a more complicated series way we're not going to get into. Let's just assume they're in parallel. So if one light burns out, the whole string does not burn out. Yes, I'm going to use this picture down here. They'd be identical resistors, but if one light bulb burns out, you still have pathways for the current to go through the other light bulbs, so they will stay lit. Circuit stuff. This one, it's always confusing, this 4-ohm resistor. You could redraw this 4-ohm resistor vertical, okay? It's the exact same thing, doesn't matter where you connect it on there. But if you draw it vertical, you see the 3, 4, and 5 are all parallel with each other, and then that's going to be in series with the other 2, and you could go from there. Okay, so this is typical of a question you might see tomorrow. You're given the resistivity. By the way, we had, I don't even remember what I said just to this class or my last one. I think I showed you a table of resistivities, various materials and the resistivity. You don't need that. If you need a resistivity, it will be given to you within the problem just like it is here. Okay, so here we're given a resistivity, a length of wire. In this case, we're given the area, very easy. I might give you the radius of it. Again, it's a circular cross section. Just do pi r squared to get that area. But it's just a matter of plugging things into the equation to get the resistance there. I already told you won't need to solve one using this equation. Just know that if you have an increase in temperature, you'll have an increase in resistance, just like this one has. That's a good one. Here's a similar question. We have a resistance, we have the length, and we have the radius. What is the resistivity? So, you know, it's the exact same question as above, just solving for something different. Okay, now that's temperature. And then the cost per kilowatt hour thing. There will be at least one like that on the test, so make sure you can do those. Brush up on that. Okay, so can we do a resistivity problem? Did I cover that, Jack, just by going through, you know, something like this? Because that's really the extent of what you would need to know. Let me know, Jack, if that covered it for you. Okay, we are at the end of that. Yeah, okay, perfect. One other thing about the test, just to give you guys a heads up, I told you it's 20 multiple choice questions. You're all going to get a slightly different version of that test. So if you're already thinking about FaceTiming your friends during the test, I'm trying to stay one step ahead of you guys. Trying. Okay. I think I've covered everything I wanted to cover. Do you guys have any questions? You've been pretty quiet. Any questions at all? I'm here to help. Yeah, good attendance. I appreciate this. I see Nicholas. I've heard him. 2 Alexes. Anna's here. Whoops, I'm scrolling really fast. Oh, man. Anna, Averill, Braden.
It's going to be circular, because I know the Wiley Plus, it was like squares and stuff, and it like changed where it was. There was like a rectangular prism.
Yeah, yeah. So if I'm thinking of the one you're thinking of, it had like a conductive block, and the current went through that. So yes, that was not a circular cross section. No, you will not have one of those tomorrow. Anything tomorrow, it's going to be a wire, and you can assume a circular cross section on that.
Okay, cool.
All right, Carrie's here. Connor, Emily, Jack, Jasmine, Kennedy, Manis, Melissa, Olivia, Richard, Rhea, Ryan. Hey, it's good to see all your names here at least. I don't see all your pictures, and that's fine. Maybe you didn't brush your hair yet today or something. Is the Wiley Plus due tonight? Yes. Okay. Ooh, I'm seeing that other question. Okay. Yeah, I'm still having it due tonight. I still want you to do it. Here's the other thing about this e-learning. Again, I'm going to be totally upfront and honest with you. If you have not heard this from your other classes, I think it's fair to fill you in on this. We've been told to go very easy on the assignments, okay? Meaning they want us to have 1 graded assignment per week, which is not much at all, of course, okay? Now, I don't want to just give you assignments every day and then let it be a surprise as to which one I'm grading. That's not fair to anybody. I'll tell you this, I will enter this test grade tomorrow, okay? So I'm saying Wiley Plus is due tonight. I'm still going to say it's due, but I'm not going to enter that into your, or should I? See, here's the thing. All right, this is new to me as well. So your grade cannot go down from where it is. So maybe I will enter it. And, you know, if it hurts your grade, it won't end up hurting your grade. Okay, Richard, I actually did do it. You should enter it. Yeah, okay, Richard. Let's assume I'm going to enter it. But like I said, if you don't do it, you know, that's your choice. If you don't do it, you won't be as prepared for the test. But then that will not count against your grade, if that makes sense. I'm trying to figure this out just like you guys are. So I apologize. I don't have good answers for that at this point. I want you to prepare for the test and do well on the test. Okay, yeah. So I'm seeing, go over problem 65 from chapter 20 in Wiley Plus, please. I'm going to write this down. Okay, so I don't have time to do that right now, Alex, but I will. I will do that. I'll either send that in an email or put that in the Canvas discussion and then let everybody know it's there. So I will address that one.
Okay, thank you. Sounds good.
Okay. All right. So we are right about 140. I'm going to get period 7 going as well. So I'm going to cut us off here. If you have anything else, put it on the Canvas discussion or shoot me an email. Otherwise, that test will be available starting at 8 tomorrow morning. Also, you're going to get the email for the next Zoom session in a couple minutes. So if you want to attend a double header, you're more than welcome to. So
Wait, so all the Zooms are always on Thursday?
no, I don't know. I wanted to do one today just because we have a test tomorrow. All right. We're going to start a new unit next week. So it may be, you know, a couple times a week. I don't know. I'll figure it out. But whenever I do them, I'll try to record it. So if you cannot attend, you can see it on YouTube. I'm going to be a YouTube star and an epic gamer. Okay. All right. Any last minute thoughts? I appreciate you all attending. This is difficult on all of us. It's interesting. I look forward to it. It's something new, but I wish we were under different circumstances. So take care of yourselves and your family. Wash your hands and stay away from everybody. All right. Okay.
Thank you.
I am gonna. Yes, you're welcome. I'm gonna end this. I will be in contact. Oh, geez. I'll be in contact whenever you need anything. All right. Take care, everybody.